Hello everyone, I am Durga Sowjanya from ECE Department, MLR Institute of Technology. I am going to give the video lecture for the subject Embedded System Design. Our today's video lecture session was differences between C and Embedded C and what is the basic structure of Embedded C programming. So in previous session, we have completed second unit with sensors, I/O devices and interfacing of I/O devices for our embedded systems. Next, going to the third unit. In this third unit, we are going to discuss about embedded C programming for 8051 microcontroller and what are the debugging tools and techniques available for embedded systems. In these topics, today we are going to discuss about differences between C and embedded C and what is the basic structure of embedded C programming. So in summary of previous session, we have discussed in previous session about the I/O devices which are used in our embedded system design like sensors and actuators. So what are the different devices available as sensors and what are the devices available as actuators? How can we interface these devices to our microcontroller in our embedded system design applications? So these are the topics we have discussed in the previous session. Now in today's session, we are going to discuss about what is C language, what are the features of C language and what are the features of embedded C language. So what is the difference between these two? And what is the basic structure of using embedded C programming for our embedded system applications. So first we are going to discuss about C language. So C language, it is a general purpose programming language and is used mainly for desktop based applications. The main features of C language include low level access to memory and it consists of only a simple set of keywords. It has a clean style so that it can be used for programming OS and compiler development. So mainly it is a general purpose programming language. So that means it is not specifically intended for a particular platform or for a particular processor. So that's why it is mostly suited for programming OS and compiler development. In nature, it uses a native platform development scheme. So that means whatever the program developed in C language for a particular platform, it is dependent only for that platform only. So that means it can be used only for that single platform and it cannot be used for any other platform. So it uses a native platform development scheme, that is the development of the application by its is a platform dependent and it can be only used on that single platform. Next, going to the embedded C language. Here the embedded C language is the extension of the C language and is used particularly to develop microcontroller based applications. So C language is a general purpose programming language and embedded C language is a microcontroller based applications for programming languages. The extensions in the embedded C language are from normal C language only. So that means whatever the operators, keywords we have used in the C language, those are all used for embedded C also. But here the main difference occurs for here is it uses the I/O hardware addressing, fixed point arithmetic operations and accessing address spaces, etc. In C language, we are not using any hardware dependent programming. So we are not considering about hardware parts are used in that design. So we are writing the general purpose programming. But here while going to the embedded C language, it is specifically intended for hardware used in that embedded system. So this embedded C programming have basic layers, basic structures of 5 layers. First, we have to use the comments and preprocessor directives, global declaration, local declaration and main function. So these are the basic layers used in our embedded C programming. So it is a cross-platform development scheme. So that means whatever the program or development of the application for a particular platform can be used for another platform also. It is a platform independent programming language, and so that it can be used for multiple platforms. So whatever the program written in a particular platform can be used in multiple platforms. The C language is suitable for only single platform applications. The embedded C language is suitable for multiple platform applications. And next we are going to the differences between the C language and embedded C language. So in general description, we know that it is a general purpose programming language. Embedded C is a extension of C and is used to develop microcontroller based applications. And C is a high level language. Embedded C is also a high level language, but it is the extension of C. C language is a hardware independent language. Embedded C language is a hardware dependent language. So that here the C language can be used to develop OS and compilers, so that the compilers are OS dependent. Here the embedded C compilers are OS independent. As we have discussed previously, it is suitable for multiple platforms, so that it is operated in OS independent way. For C language, the standard compilers can be used to compile and execute the program. Here, embedded C specific compilers are to be used for based on the hardware or microcontroller based output. So whatever the processor we have used in our embedded system, so depending on that hardware components used in that processor or my embedded system, so the compiler will be specific to that processor. Here we can use the standard compilers. So the popular compilers used for C programming are GCC, Borland Turbo C, Intel C++. So the compilers which are developed for embedded C are Keel compiler, Bipom electronic compiler, Green Hill software. And next, usability and application. That is, what are the advantages of using C language and what are the advantages of using embedded C language. Here the C language has a free format of program coding and is specifically used for desktop applications. As it is a general purpose programming language, it is suitable for desktop applications. Thus optimization is normal and it is very easy to modify and to understand the C language. But bug fixing is very easy in a C language program, as it is a hardware independent and platform independent. It supports other programming languages during application. So here input can be given to the program while it is running only. So these are the advantages of using C language. While going to the embedded C language, here the formatting will be depends on the microprocessor that is used in our design and is used for limited resources like RAM and ROM. So depending on the ROM and RAM capacity only, the program will be done. High level of optimization should be there, and it is not easy to modify the embedded C language. As it is hardware dependent, it is not easy to change the special function registers or the register contents in the processor by using the programming. Bug fixing is complicated. It supports only the required processor of the application and not the programming languages. Since the registers and the special purpose registers, the special function registers and the memory, so which are used for that particular processor, are different for any other processor. So that's why it supports only the required processor application programming. Only predefined input can be given for the running program. So whatever the input we need to define based on the hardware components used in the design. So those are only to be given as an input. So the applications of C programming are the logical programs and system software programs. So basically it is used for developing OS and compilers. So the applications of embedded C programming are the DVD, TV and digital camera. So these are intended for the programming which is written for these applications or are written specific to that applications only. So those are not used generally. So whatever the program we have written for general processes, those are not implemented for these devices. So the program which is written for these devices using the embedded C are specific to those devices only. And next, what is the basic structure of embedded C program? So we have already discussed the what is C language and what is the embedded C language and what are the differences between C language and embedded C language. So now here while going to the embedded C language, for most of the embedded system applications, so we are going to prefer embedded C programming only. So now we have to learn what is the basic structure of embedded C program and what are the components and what are the methods to be used for writing the embedded C programming. So the basic structure of embedded C programming contains the template of the embedded C programming. So it is also called as template of the programming. So here first we know that for every program we have the comments. The multi-line comments in the embedded C are represented with slash and star with and ended with the star and slash. So the comment begins with this symbol and ends with this symbol. The single line comments will be begins with double slash at the start of the line. The preprocessor directives, it includes hash include or hash define. So hash include, hash define, these are called as preprocessor directives. The global variables. Global variables means the variables which are declared in the program, so should be available and should be used anywhere in the program. The function declarations. Next we need to write the function declarations. So that is whatever the functions which are implemented for that entire application or should be declared. And the main function. So main function means here only the execution begins. Here it starts with the open parenthesis and the main function will ends with the closed parenthesis. In between these two parentheses, we have to write our main application. Here in this main application, first we need to declare the local variables. So local variables means the variables which are declared and which should be available and used in that particular function only. Function calls. So here whatever the functions we have declared previously, so we need to call those functions. And next, infinite loop. Infinite loop means while. So while loop should be used for defining the infinite loop. That means whatever the program we want to repeat continuously. So that should be defined as infinite loop and it should be written as while. The statements which are required for that application. So next, after completion of the main function, we will go to the function definitions. Here we are calling the functions in the main program. So now we need to define those functions. Here the function definitions which are used for defining the functions. In these functions, it can be open with the open parenthesis and we have the closed parenthesis, and in between these two, we need to write our function processing. First, we need to declare the local variables. So these local variables are confined to that function only. So that means these are available to that function only and these are not used anywhere in the program. And the statements which are used for defining that function. So this is the template of the embedded C program. So first, we need to write the preprocessor directives, right, like hash include or hash define. And next, we need to declare the global variables and we need to declare the function names, function declarations, and next we are writing the main function, and after that we are going to write the functions. So in the main function, we need to declare the local variables first and we need to call the functions. And we need to write the statements which are used for defining our application. In functions, we need to declare the local variables used for that particular functions. And we need to write the statements which are used repeatedly for that function. So whenever we call that function, so this can be used repeatedly whenever we call the function. So the statements which are used for defining the function. So this is the template of the every embedded C program. For writing any program in embedded C language, we need to follow this template. So in this template, we can use the comments, that is single line comments with double slash, can be at anywhere. So like that, slash and star and ended with star and slash. So these also can be used at anywhere in the program. So we are not having a specific place to use these comment lines. Next, we can go in detail about these terms. So first, comments. So comments are readable text that are written to help us to understand the code easily. So that means whatever the program written in programming language terms, it should be understood by the user using these comments only. So these comments are used for specifying the user whatever we have written in our program. So if we have written in our program, right, for I equal to 0, I plus plus, I greater than 10. So that means here it indicates that I started with the 0 value and we can increment I value for every rotation up to the rotation of less than 10 only. So it can be easily understood by the user when we have written the comments in these comment lines. Like here we are using the for loop for 10 rotations for count the value of I from 0 to 9. So when we have written like this in the comment lines, it should be easily understood by any user. So whatever we have written in the program. So they are ignored by the compiler and do not take any memory in the final code. So these are not used by the compiler, since these are the comment lines. These are for only user understandable purpose only. So these are not compiled. So we have to compile only our programming part only. And there are two ways to write the comments. One is single line comment and the multiple line comments. Single line comments are denoted by double slash. The multi-line comments are denoted by slash and star. Next, preprocessor directives. A preprocessor directive in embedded C is an indication to the compiler that we must look into the file for symbols and are not defined in the program. So we can define a preprocessor directive which are already defined in our processor by the manufacturers. So we can use directly that preprocessor directive in our program to indicate that the symbols which are defined in our program are related to these preprocessor directives. So in C programming also we can use the preprocessor directives which are defined using the hash symbol. So whenever we have used the hash symbol to define any directive, it indicates that it is a preprocessor directive. Like hash include, hash define. So these symbols indicates that whatever the symbols we have declared here and those are used in our main programming. So those belongs to these directives. In embedded C programming, we usually use the preprocessor directive to indicate a header file specific to the microcontroller which contains special function registers and the bits in those special function registers. In normal C programming language, we can use only hash include, hash define like that. But in our embedded C programming, we can use some header files like hash include register 51.h. See, it indicates that register 51.h is the header file of 8051 microcontroller and all the registers, all the special function registers in that 8051 microcontroller which are used in our program or comes under this directive. So in case of 8051, Keel compiler has the file register 51.h which indicates that these are comes under the special function registers and registers which are used in that processor or to be used in our programming. So which are written at the beginning of every embedded C programming. Next one is global variables. Global variables are nothing but these are global to the program. So that means they can be accessed anywhere in the program. Local variables. Local variables are reverse for the global variables. That means these are a particular to that function only. So these are confined to their respective function only and those are available and should be used in that function only. And those are not used globally. Main function. Main function means every C program or every embedded C program has one main function only and it indicates where the execution of the program starts. So these are the topics which are discussed in the present session. So we have discussed the summary of previous session and we have discussed what is C language and what are the features of C language and what is embedded C language, what are the features of embedded C language, and we can discuss what are the differences between C and embedded C, and we have discussed the basic structure of embedded C programming. So these are the topics discussed in the present session, and in next session we are going to discuss about what are the keywords, what are the data types, what are the variables used in our embedded C programming. Thank you.